Hi, everybody. This is Tim Urden, author of Statistics in Plain English. And in this example, I'm going to show you how to calculate a Mann-Whitney U statistic. Just sort of go through the steps of calculating this by hand. Hopefully you won't have to do this, but it's not a bad idea to know how. So here's what I did. Suppose that I wanted to do a study of the heights of students in, say, a fourth grade class, and I get a sample of 5 girls from the class and 5 boys from the class, and I measure their height in inches. And so over here, I've got the heights of the 5 girls, 45 inches, 39 inches, 60 inches, and so on. And over here, I've got the heights of the 5 boys. So what you do in a Mann-Whitney U-test is you first arrange the data. When you combine the two groups and you arrange the data from smallest to largest. And that is this row here. So that is 10 scores, 10 different heights in inches arranged from the smallest to the largest. And then you assign a rank to each of these. So the smallest gets a rank of 1, the largest gets a rank of 10. It goes like that. So now each score has a rank. And the next step is to then assign the ranks back to the individual cases. So this girl up here, her score was 45, and her rank in this combined data set is 4. 39 has a rank of 2. 60 has a rank of 9. 52 down here has a rank of 7. 43 has a rank of 3, like that. And then I do the same for the boys. 48 has a rank of 5. 62 has a rank of 10. 37 has a rank of 1. 56 over here has a rank of 8. And 50 over here has a rank of 6. The next step is to add up or sum the ranks. That is a sum sign. I need to apologize for my handwriting. It's awful in the worst of circumstances, but when trying to write on an iPad, it's even worse. So anyway, I add these up. 4 plus 2 is 6, plus 9 is 15, plus 7 is 22, plus 3 is 25. And then I do the same for the boy sample. Sum. 5 plus 10 is 15, 16, plus 8 is 24, plus 6 equals 30. Okay. Now, what I do is I take the smaller of the two, which in this case is the girls' summed ranks, and I calculate a U statistic based on this number. So the formula for the U statistic is right there. U equals the sum of the ranks for one of the groups minus the sample size n for that group times n plus 1 divided by 2. So it looks a little funky, but it's not very difficult from a math perspective. So let's plug in the numbers. The sum of the ranks for the girls sample is 25 minus, there are 5 cases in the girls sample, times 5 plus 1 is 6, divided by 2. U equals 25 minus 30 divided by 2. U equals 25 minus 15 equals 10. So U equals 10. that's my observed U value. And then we need to look in Appendix F and find the critical U value and see if the observed value is smaller than the critical value. Now, remember, for a U statistic to be statistically significant, the observed value, the one that you calculate, needs to actually be smaller than the critical value. Okay, so if I look in Appendix F, keep in mind, N1 and N2, there's 5 cases in each group. So I'm going to look down here for 5 and across here for the column that has 5, and I find a critical U value for a two-tailed test with an alpha level of 0.05 of 2. So my critical U value is 2. So my critical U value is 2. That is smaller than my observed value of 10. And now what I conclude is that because my observed value is larger than my critical U value, my result is not statistically significant. And there is no difference in the median rank of boys and girls in their height in this class. So that's how you calculate a Mann-Whitney U. And pretty straightforward. It's a little bit tedious. There's several steps, but nothing too difficult about it. I hope that's helpful.